This is my 16-bit adder subtractor circuit. This is the zoomed out view just so you can see the whole circuit. I've linked 16 full adders together, and this is my input for A, and this is my input for my B number. They're both in reverse, and so is my adder, so you can consider this the 0th bit all the way up to the 15th. For my 16-bit adder subtractor, I use Logisim. This is my full adder circuit. Just like DLSim, it allows you to make subcircuits, and this is just a subcircuit. I have my carry in, I have my A and B inputs for whatever index I am adding or subtracting in my two binary numbers, and I have my add/sub input, and when this is a 1, it means I'm subtracting, and I XOR the bit from B to flip it. And then the rest is what you would expect from a full adder. To start, I will give a demo of addition with my circuit. I will set my A input to 5, so 1, 0, 1. My least significant bit is on the left and most significant is on the right. Same goes for my B input and the sum from my ripple carry adder. And I will set my B input to 7, which is 1, 1, 1. This produces an output of 12, or 1, 1, 0, 0, and my circuit performs this correctly. And there's obviously no carry out from the final full adder. If I change the carry bit to a 1, I would expect my sum to be 13, or 1, 1, 0, 1. This happens because this carry-in bit goes in here and produces a sum. Here I will demonstrate subtraction. First, I've set my A to 1, 1, 0, or 6, and B to 1, 0, 0, or 4. And 1, 1, 0 minus 1, 0, 0 should give me a value of positive 2. I've set add sub to be 1, which means I want to perform a subtraction, and what that does is sends a signal to all of my full adders into this AS port. And if we look at my circuit, that says when add/sub is set to 1, we want to perform a subtraction, so we XOR our B bit, which flips it. Now I'm going to go back to my main circuit. And here you can see how the subtraction is actually being performed, and we do in fact get 2, 1, 0, and here the borrow out bit is set because there is no carry out of the most significant bit when subtraction is performed. Instead of doing 6 minus 4, this time I'm going to do 4 minus 6, which produces a value of negative 2. Our most significant bit is set to 1 because we're in 2's complement, and our final carry out is not set, or final borrow out. Now, if we toggle this carry borrow bit, what should happen is instead of doing A plus inverse of B plus 1, we just want to do A plus inverse of B. And that's what happens because we do not bring in this 1 for the carry in, and we invert B and we add A. And we get the correct result.